Let's talk about what AI actually is. Obviously, it's here to stay, it's very good, and it's only going to get better. However, it's also very overwhelming. There's so much out there about what it is, all this doomer mentality about how it's going to take over the world. And I felt the same way. I just felt like there was way too much going on. I don't have a background in computer science or engineering. And so I decided to learn about it and basically just teach as I learn. The reality is, AI is here and it's here to stay. And I feel like the only two options that we really have are either learn it and learn how to win with it or lose and get left behind. But like anything else, if you understand the foundations and the basics, I think you can learn anything, and this is really no different. So let's actually start with what AI is not, because obviously, because of social media, Hollywood, there's all these misconceptions of what it actually is, at least in its current form. AI is not Skynet or the Terminator or something that's trying to take over the world on its own. It doesn't have feelings, it's not secretly plotting anything, and it doesn't think the way you and I think of thinking. The AI that we're talking about today, it's not a conscious being, it's simply a tool. It's a very powerful and a very impressive tool, but it's a tool nonetheless. The gap between what AI can do today and what science fiction imagines is still enormous. So keep that in mind. Now, it's progressing very quickly, and who knows how far we are from that gap being filled. But for now, it's a tool, and that's how it should be treated, not as some superpower or this super complex thing that you can't understand. So, simply put, AI is basically software that's been trained to get very good at a specific task by processing enormous amounts of data and learning patterns from it. And that's truly the core of it. Now, this whole process of data processing and finding the patterns, you can call that training. Now, let's talk about what training actually means in this context. When we think of traditional software, it basically works on rules. There's a team or a programmer that sits down and writes out all this code, which is basically instructions for how that software should act. So if the user clicks X button, do this. If the number is greater than 10, do that. And the computer or the software follows those rules exactly every time with no deviation. And that's how traditional software is basically built. It's very powerful, but it's rigid. You can only do what a human explicitly programmed it to do. In the case of AI, we have something called machine learning, which works a bit differently. So instead of writing out the rules and feeding them to the system, you feed the system with a bunch of data and let it figure out the rules by itself. So if you think about how you learn how to ride a bike or really any skill, no one handed you a physics textbook explaining the mechanics of balance and momentum and center of gravity. You got on the bike, you fell off, you cried a little bit, you adjusted and you tried again, and eventually the brain worked it out through experience. AI learns in a very similar manner, just with a bunch of data. And the idea with this is that if you give it enough examples, the computer can learn how to recognize the patterns and make predictions without being explicitly told how. And the first things first, in this case, you start with a lot of data, millions, maybe billions of examples, photos, text, audio, numbers, whatever is relevant to that particular task. And then the second thing is that there's a model that's being fed this data. It's basically a mathematical structure. You can think of it as a very complex spider web of code where each weave is talking to one another. And essentially, this structure is called a neural network, which is basically inspired by the way neurons work in a human brain. There can be millions or billions of these connections within a model. And then you train the model, so you feed all that data through that neural network. And for each example, the model is going to make a guess. And at first, those guesses are going to be terrible. It's essentially going to be random. But then each time that system compares each guess to the correct answer, and it measures how wrong it was, and it makes tiny adjustments to all these little networks to get to the right answer. And essentially, every time it measures this error and it adjusts itself, it's called backprop, and it happens millions of times across the entire data set. And then basically, over time, the model is going to get better because it just keeps iterating. And in AI language, each of these iterations is basically called an epoch. And through this iteration, all those dials and switches and those connections between the neural networks are basically tuned in a way that it can now produce accurate predictions based on the patterns that it's seen. And then after that, you test it. You give it data that it's never seen before to check that it's genuinely learned something rather than just memorizing the training examples. And that process is called generalization, the ability for the AI to apply what it's learned to new situations that it wasn't trained on. So again, the whole process of machine learning, feeding the data, making predictions, measuring the error, adjusting, and that's the long and short of how machine learning works. Obviously, there's a ton more detail we can go into, and we'll make a different video about machine learning, but for now, that's the foundational concept. Now, we mentioned that for machine learning, you need a whole lot of data, but how does the system actually work with that data? So if you just dump a bunch of pictures of cats into an AI program, you can't really expect it to just automatically recognize cats. The model needs to know which photos have cats and which ones don't, and that information, otherwise known as the label for that piece of data, is what it learns from. So how does that actually happen? So in many cases, it's actually human beings that label this data. It's called data labeling or data annotation, and it's an entire industry. So people will literally sit there and manually tag images, transcribe audio, highlight objects in photos, or classify text. So there is significant human involvement initially before the AI can just start teaching itself. And then there's also the concept of deep learning, which is essentially when the machine learning uses neural networks with many, many layers to learn something. So each layer in that neural network or that spider web we talked about earlier, it learns to recognize increasingly complex features. So for example, in an image recognition system, the first layer might only pick up on edges and corners. And then the middle layer might combine those into shapes and textures. And then the deeper layer might recognize parts of objects. And then the final layer might put all of that together to identify what the whole thing is. And this layered approach is what allows deep learning systems to handle very complex tasks like understanding speech, translating languages, generating images. This deep learning is behind a lot of the stuff that you see nowadays in AI, whether it's ChatGPT or image generators, voice assistants, some of the more impressive AI tools out there. It's based on deep learning. Now, the concept of AI actually isn't new. It's been here since the 50s. Back then, though, obviously it was very simple forms of AI, and they went through things that are known as AI winters, where basically funding dried up, the hype died down, and progress just stalled because the technology just wasn't there yet. Where we're lucky is that we have the internet. So that takes care of that data side of the equation because there's just so much out there. So that took care of the raw materials part that needs to be put into these models. And then the other key thing was the GPU. The GPU is the graphics processing unit, and this was originally designed to render video games. So video games are obviously just code, and then what they found were that these GPUs that they were using, they were really good at the kind of mathematical operations you need to train those neural networks or those spider webs from earlier. This is where companies like Nvidia come in. They were originally making these video game chips, but now they're almost entirely an AI company making these GPUs, which is vital for all these AI models. And remember, AI is not something to be scared of. It's something that, whether you deliberately do it or not, you're using it every day. Every time Netflix recommends a show you end up loving, basically that machine learning model analyzes your viewing history, millions of other users' behavior to predict what you might like. Anytime your Gmail tries to finish your sentence, it's using a language model trained on enormous amounts of text based on your previous text, other people's text, to predict what those next words might be. When your bank flags a suspicious transaction, it's basically a fraud detection model. It tracks your patterns of normal behavior and then abnormal spending, and it flags that. So AI has pretty much been embedded into the background of your life probably for a long time. The only thing that's changed recently is that it's become conversational and generative, meaning you can talk to it directly in plain English and give it tasks and it will produce stuff for you, text, images, code, and that's what makes it generative. And then when things really changed was basically the end of 2022 when ChatGPT came out. And ChatGPT is basically what's called a large language model. It was trained on an enormous amount of data over years and years, and then when it finally came out, it basically reached over 1 million users in 5 days. Just for context, it took Netflix about 3.5 years to reach that number. And this was the first time where the layman person could just sit down, talk to AI in regular English, and a bunch of seemingly magic would happen behind the scenes, aka code, and it would spit out a coherent, natural language answer. And there's a lot of things AI can do. There's new tools coming out every single day, and that's why it's so overwhelming. It can write, it can summarize, it can answer questions, generate images. There's concerns of a ton of jobs going away. And that's not meant to scare you. It's just the reality of how powerful this tool is and how much better it's going to keep getting. So again, don't stand there with a horse trying to prevent cars from happening. It's here and it's here to stay and it's only going to get better. So it's much better if you accept that and just start to learn and figure out how you're going to succeed with it. Now, obviously, AI is far from perfect. A big problem with it is hallucinations. It's gotten a little bit better at this, but it's still an issue where it will confidently tell you something that's actually completely wrong. And it's formally called a hallucination, basically when a model generates a totally plausible sounding answer, but it's completely inaccurate information. Because remember, how does it work? It's predicting what the words should be based on the patterns that it understands, not because it actually inherently knows anything like how you know your name. This is why if you're going to use it, it's always important to verify that information that it's giving you independently from trusted sources. And that's the key thing. Even though it's spitting out realistic sounding things or looking things, it's not understanding the way you and I do. It's a really good pattern matching and language prediction machine, but they don't have any lived experience or common sense or genuine comprehension in the human sense. So they can sound wise, but it could be complete garbage that it's telling you. And keep in mind also, we talked about how these AIs are trained with the data labeling and what you put into it. And the reality is, whatever you put in is what you get out. So if you feed it with garbage, it's going to put garbage out. If there's biases in the data that it was fed in the way that it was trained, then it's going to spit out those biases in its answers as well. So the bottom line is that AI is not some magical thing. It's not a monster. It's not here to take over the world yet. It's basically very powerful software that's been built on decades of mathematical research and training and huge amounts of data that have been facilitated by the availability of the internet and those GPUs that we talked about. And at its core, it learns by example, finding patterns in the data at scale. It feels overwhelming. There's a ton of information out there, and it's a constantly changing landscape. We're basically living through the creation of the internet, but in our generation. And again, the only way is through it. It's important to learn what it is. It's important to play around with it, see how it can help you in your life, and figure out how to win with it, because I don't know how, but I do know for a fact that things are going to change because of AI. So that's it for this one. Very foundational, high level stuff. High level meaning just from a broad point of view. We obviously didn't get into details or the science behind these things. And to some degree, you don't really even have to. We're going to make tons more videos about different concepts and getting a deeper understanding, as well as how people have used AI so far, what people are doing with it, how they're building with it. So follow along for that. You can join our newsletter and our community. Everything's free, at least for now, and just keep learning. All right, we'll see you next time.